everyone, this is Baz from the Education Hamper. Today we will be working our way through a Sevenoaks School Year 7 11 Plus Maths exam. This one was set in January 21 for entry into September 2021. Just from the offset, near the end of this paper there are some quite difficult questions. The time allowed here is 1 hour, and the expectation is that not all the students will get through to those end questions. There aren't too many more extra marks for those, so we want to be clear is that we work through methodically, get the questions that are simple right, and the marks will accumulate that way. And if we have time at the end, let's go through those difficult questions if you're sitting the exam. Today I will go through all the questions with work solutions, so you know how to answer those. So let's kick it off. Before I do kick off though, remember to pause when I read the question, give it a go, and then we work through the solution together. So first thing, as always, name. In my case that is the Education Hamper, and during the exam if candidates were to sit this, or yourself are going to sit this, you would write your current school down here. Again, 1 hour. This equipment is what's required. Calculators are not allowed, so plenty of mental arithmetic here. Show all your working. That's important here. Even if you do some mental arithmetic that's incorrect, but you get the working right, you will get marks for it. So let's be clear about that. Concise, methodical. Let's get through the paper. So let's kick off with question 1. 41 minus 101 plus 29. Right, so the first thing I would do is subtract 101 from 41 from 101. So 101 minus 41. 1 minus 1 is 0. And here we've got to steal a 1. That will give us 6. So there you go, 6. But we're actually doing the opposite here. It's 41 minus 101. So you'll have to put a minus in front of this. So therefore we get minus 60 plus 29. Now what do we know here? So minus 60 plus 30 would give us minus 30. So minus 60 plus 29 would give us minus 31. So the answer here is minus 31. Next question. 625 divided by 5. Just a moment. Now some of you may be able to work this out in your head, but I'll do it via the long division, so just in case you don't know how to work it out. So 5 into 6 to 5. How many 5s in 6? 1. Bring the 5 down. 6 minus 5 is 1. Bring the 2 down. How many 5s in 12? There are 2. That will give us 10. Bring the 5 down. 5 in 25, that's 5. And then final, you subtract the 2, that gives us 0. So the answer here is 1, 2, 5. So 51 times 11 is part C. So let's do 51 times 11. As always with multiplication, start on the right hand side. 1 times 1 is 1. 1 times 5 is 5. So we've done the units. Now we're going to move on to the tens. So because we move on to the tens, we'll put 0 here. 1 times 1 is 1. 5 times 1 is 5. And then we add these two. 1 plus 0 is 1. 5 plus 1 is 6. And then we have 5. 561 is the answer here. So question 2. Convert the following fractions to decimals. So 3 divided by 10. Here we will write down 10 into 3. How many 10s in 3? That we can't do, so we need to put another 0 there. But by doing that we need to put a decimal place up to the top. 10s into 30 is 3. 30, subtract it. That gives us 0.3. Right, next question. 17 divided by 50. So let's start like that. And if I do it properly, 50's into 1, we can't do. Let's put a 0 there. 15 into 17, can't do. Let's put a 0 there. Now we need to put another 0 here, but by doing that we need to put a decimal place. 50's into 1, 70. So if you do 50 times 3, that gives us 150. So let's do that. Subtract it. 0 to 0. 50's into 20 we can't do, so we need to bring another 0 into it. 50 into 200. 50 times 4 is 200. So we get 200, that gives us 0. So the answer here will be 0.34. So 14 divided by 20. So in this case we can simplify this. If we divide the top and bottom by 2, so 14 divided by 2 is 7, 10 divided by 2 is, no sorry, 20 divided by 2 is 10. So, and to make this a little bit simpler, yeah, in fact let's just do the division like this. So 10, 7, 10s in 7 we can't do, so we need a 0, we need to bring another 0 in here. How many 10s in 70? That gives us 7, bring the 70 down, 0. So here we have an answer of 0.7. Great. Question 3. Fill in each box with either a plus or a minus to make the calculations true. So 6, missing sign, 14 is equal to minus 8. Important thing here is that we have a minus 8, so we have a small number, sign, big number. So automatically we think we've got to go smaller because it's a negative number. So we'll do a minus, and if you do that in your head, 6 minus 14 is in fact minus 8. So part B, minus 3, missing sign 6, missing sign 11 is equal to minus 8. So minus 3 plus 6 will give us plus 3. Plus 3 minus 11 will give us minus 8. I think therein is the answer. Question 4. Fill in each box with a number to make the calculations true. So 12 plus a missing number times 5 is equal to 100. So we need a number here that will make a total number that we multiply by 100. Multiply by 5 gives us 100. So 20 times 5, 5 times 0 is 0, 5 times 10 is 100. So 20 is the number we need. So what do we need to add to 12 to make 20 and 8? Part B. So we have a missing number, minus 6 divided by 5 is equal to 9. So if we focus on this side first, that looks like if we multiply by 5, that will be able to balance this equation out. So 9 times 5 is equal to 45. So we need to make 45. So yeah, so this number has to be 45 divided by 5 to give us 9. So that would be 51 minus 6. So let's just make sure that makes sense. 1 minus 6 we can't do, so we steal a 1. 11 minus 6 is 5. Then we bring the 4 down, 45. So that's the answer, 51. So next question. 5. A plank of wood is 4.6 meters long. These two lengths of wood are cut from the plank, 88 centimeters and 1630 millimeters. What is the length of the wood left? So we have 3 different units here. I think I'm going to make them into a similar unit. In this case I will choose centimeters. So let's label each of these 1, 2 and 3. So number 1, 4.6 meters to centimeters. So to convert from meters to centimeters we times by 100. So 4.6 times 100, that gives us, so we need to move the decimal place 2 places. So 1, 2, 460 centimeters. So part 2 we know is 88 centimeters and 3. Okay, so to convert millimeters to centimeters we need to divide by 10. And then we can remove the zeros here. 1630 divided by 10 is equal to 163. So now we have consistent units. So 163. Now the question was, these two lengths of wood are cut from the plank, so it's a subtraction question. So the total length of the wood minus these two portions would give us what wood is left. So let's write that out. 460 centimeters minus 163 centimeters minus 88 centimeters. Work this out step by step. So 460 minus 163. So 0 minus 3 we can't do, so we need to steal a 1. 5, 10. 10 minus 3 is 7. 5 minus 6 we can't do because that's smaller than the bottom, so we steal a 1. That gives us 15. So 15 minus 6, that gives us 9. 3 minus 1 is 2. So here we have 297, but we also need to subtract this 88 centimeters. So 297 minus 88. So 7 minus 8 we can't do, so we steal a 1 from this side. 8 plus 8 is 17, so 8 plus 8 plus 8 is 16, 8 plus 9 is 17. So 17 minus 8 is 9, 8 minus 8 is 0, and then we 2. So that's equal to 209 centimeters. Now it's up to you how you want to answer this. I mean, centimeters is probably fine, but because the original length was in meters, I may convert this to meters. So 209 centimeters to meters is divided by 100, divided by 100. So when we multiplied by 100, we went two decimal places to the right. When we're dividing, we go 2 decimal places to the left. So 1 and 2. So that will give us 2.09 meters. So I think the total answer will be 2.09 meters. Make sure you put the units in here. It's always good to be consistent all the way through. Question 6. Place the following fractions in the boxes below by arranging them from smallest to highest. Okay, let's just highlight smallest to largest. Sorry, largest. 7/18, 4/9, 5/12, 1/3. So here I think the easiest way to do this is to find a common denominator. So we have 18, 9, 12 and 3. In this case, let's just see. 18, go through the multiples. 36, 54, 9, 18, 27, 36. So we have 2 common multiples here, 36. So let's see what about 12, 24, 36. So we've got 3 here, and then the last one. Alright, so 3 times 12 is 36. So 3, 6, 9, 12, etc. 36. So okay, so let's make sure we're clear about this. So we need to multiply this one by 2, 4/9 multiplied by 1, 2, 3, 4, 5/12 multiplied by 3, 1/3 multiplied by 12. This will give us a common denominator. So 7 times 2 is 14 over 36. 4 times 4 is 16, 9 times 4 is 36, 5 times 3 is 15, 12 times 3 is 36, then we have 1 times 12 is 12, and 3 times 12 is 36. So from the smallest to the largest. Okay, so the smallest is the 12 over 36. So hold on, 12 over 36, which is equivalent to 1/3. So 1/3. That one points to that one. 15 over 36 is same equivalence to 5/12. And that one is 7/18. That one is 4/9. Okay, so the next smallest is 14/36, which is equivalent to 7/18. Then 15/36 equivalent to 5/12, and then 16 over 36 equal to 4/9. That's being the largest. So that's the order we have here. Question 7. Okay, you go into a local bakery shop and you see the following items are on sale. For each item, calculate how much it will cost. A A pie originally costing £2 has been reduced by 12%. So it's originally £2, and then we've got to see a reduction of 12%, what the total of that is. So I think the first thing I'll do is I'll change the pounds to pennies, because we're dealing with whole numbers then. So £2 times 100, which gives us pence, gives us 200 pence, and then 12%. So in the case of 12%, 12% as a fraction is the same as 12 over 100. So that's just a percentage thing. Any percentage number is always over 100. So 12% of 200. So let's see. So if we multiply the two together, that will give us what 12% of 200 is. Now, the simplest thing to do here is try and cross off the noughts from the denominator to the numerators. So to make it clear, so this is 200 over 1 to make it easier. So we can cross these two off, we can cross these two off, and then 12 divided by 1 is 12, times 2 is 24, so that's 24 pence. Now it's been reduced by 12 pence, so here is an important step here, that we need to subtract these two from each other. So 200 minus 24. So 0 minus 4 you can't do, 0 minus 2 you can't do, so we're stealing a 1 from this side, putting it there. That gives us 10 divided by 2. Then we steal another 1 from here, which gives us 9 and 10. 10 minus 4 is 6. 9 minus 2 is 7. And 1 minus 0 is 0 is equal to 176 pence. But because the original question was in pounds, we're going to have to convert this to pounds. And to convert to pounds, we go from pence to pounds is divided by 100, which is the same as moving the decimal place 2 places to the left. So I'll do that over here. 176 pence. 1 divided by pound is, you move the decimal place from here. 1, 2, which is equal to 1.76. So let's be clear with this 6 over here. So the answer is 1.76 and a pound sign there. So £1.76. So pie originally cost £2, and by reducing it by 12 pence, the cost of the pie now is £1.76. Part B. A donut originally cost 80 pence has been reduced by 20%. Again, highlight the key things. 80 pence reduced and by 20%. So the same thing. Let's keep it as pennies. So 80 pence is the donut, and then the equivalent percentage. So 20% is equal to the same as saying 20 over 100. Now, much as we did in the previous example, we multiply these two. So 20 over 100 multiplied by 80 over 1, just for clarity. So one of these zeros can be taken off this side, one of these zeros can be taken off this side. So 2 divided by 1 is 2, and then 2 divided by 1 is 2, and then multiplied by 8 is equal to 16. And in terms of units, that's pence, but the second step is that it's reduced by that, so we need to do that same subtraction. So 80 minus 16. Let me be a bit clearer here. 80 minus 16. 0 minus 6 we can't do, we'll steal a 1. 10 minus 6 is 4. 7 minus 1 is 6. So the answer here is the donut is now worth 64 pence. Question 8. A factory makes wooden cubes. So this cube here, it looks like each side is 3 centimeters. They are packed into large boxes. Right, so how many wooden cubes can be packed into one large box? Okay, so we've got to see how many of these little cubes can fit inside this box, and they'll fit in the horizontal and the vertical. So I think the easiest way to do this is kind of a ratio based method. So how many boxes will fit in the base? So if we know how many are in the base, then we can work out how many in the height, and then just add the two numbers. So we know the length of this is 27 centimeters, and we know that each cube is 3 centimeters. So if we divide that, 27 divided by 3, which we know from our 3 times table is 9. That gives us 0. So 9 boxes fit along the length, but we also have a depth here, so 12. So same thing we do here is the depth is equal to 12 divided by 3, again 3 times table, that gives us 4. So total number of boxes in the base is equal to 9 times 4, but we also have a height, so the height is 15. So again, height is equal to 15 divided by 3, which gives us 5 boxes. So total boxes in container is the multiplication of 9 times 4 times 5, which is the width times depth times height. So 9 times 4 is equal to 36. So 36 times 5, 6 times 5 is 30, 5 times 3 is 15, add the 3, 18. So 180 boxes. Evaluate the following fractions, giving your answer in its simplest form. So part A has 2/5 divided by 6. So let's write this out. 2 divided by 5 divided by 6 over 1. And you know, with division you can flip this side of the fraction to a multiplication. So 2 over 5 times 1 over 6 is equal to 2 over 30. And if we divide both denominator and numerator by 2, that gives us 1 over 15. So the answer here is 1 over 15. Question 2. 3 1/3 times 5 2/5. So these are improper fractions. So we need to multiply this out. That's probably the best way. There are 2 different ways of doing this, but let's just multiply it out. So 3 times 3 is 9, plus 1 is 10. 10 over 3 multiplied by 5 times 5 is 25, plus 2 is 27 over 5. So that gives us 270 over 15. So here we can divide by 3. That gives us 90 over 5, and 90 goes into the 5 times table. So if you know 18 times 5, 8 times 5 is 40. 5 times 1 is 5, plus the 4 is 90. So the answer here is 18. Question is part C, 1/4 plus 1/3 minus 1/2. So let's write this out. 1/4 plus 1/3 minus 1/2. So here we need to get a common denominator here. So what goes into all of these is 12. So if this one needs to be multiplied by 3, by 4, by 6. So that gives us 3 over 12 plus 4 over 12 minus 6 over 12. So that's the same as 3 plus 4 minus 6 over 12. 3 plus 4, 7, minus the 6, which is equal to 1. So that gives us 1/12. 1 over 12 is the answer. So here we have question 10. The table below shows a timetable for 4 trains. Train B and C do not stop at all stations, as indicated by the arrows. Use the timetable to answer the following questions. Let's take a look at this. So stations are Birmingham New Street, Birmingham International, Coventry, Leamington Spa, Banbury, Oxford and Reading. So as it mentioned, train B does not stop at Leamington Spa or Banbury, goes straight on to Oxford. And train C doesn't stop at Banbury or Oxford, and it goes on to Reading. So part A. What time does the 10:05 train from Birmingham New Street arrive in Oxford? So first thing we need to do is to find the 10:05 train here. So Birmingham New Street is the station we need. Train A at 9:40, train B at 10:05, and train C is 11:05. So we focus on the 10:05 train, and we need it to arrive at Oxford. There we are. So it arrives at Oxford at 11:24. The answer here is 11:24. B. Which train is the fastest train from Birmingham New Street to Oxford? Let's zoom back on this one. So Birmingham New Street to Oxford. So here we have train A, Birmingham New Street from 9:40 to Oxford at 11:06. So 9:40 to 11:06. Train B is 10:05 to 11:24. Train C does not stop at Oxford, so that's train we can miss, and train D. So it's between these three trains. Train D starts at Birmingham New Street at 12:35 and it arrives in Oxford at 13:52. So what we need to do is to work out the difference in time in all of these and then see which one is the fastest train. So train A, 9:42, 10:06. Confirm that, 10:06. Alright, so 9:42, 11:40. So first thing we do is 9:42, 10:40 is 60 minutes. And 10:40 to 11:06. So 10:40 to 11 is 20 minutes plus 6. That gives us 26 minutes. Therefore 60 plus 26 is equal to 86 minutes. Alright, train B starts at 10:05 and it arrives at 11:24. So therefore we have 10:05 to 11:05 is 60 minutes. 11:05 to 11:24. So 11:05, 11:15 is 10 minutes, 11:25 is 20 minutes, but we're one less than that, is 24. That's 19 minutes. Therefore we have 60 plus 19, 60, 70, 79 minutes. Right, next one, train C is 12:35 to 13:52. 12:35 to 1:35 is 60 minutes. So 13:35 to 13:52. So 13:35, 45 is 10 minutes. 50 is 15, plus another 2 is 17 minutes. Therefore we have 60 plus 17, 60, 70, 77 minutes. So the answer here is the train that's fastest is train C. Right. Part C, you get to Birmingham International at 11:12. So let's underline that, 11:12. How long will you have to wait for a train to Banbury? So we get to Birmingham International at 11:12. So if we arrive Birmingham International, which is this one, arrive at 11:12. So if we arrive at 11:12, which is before 11:15, so we get that train how long will you have to wait for a train to Banbury? Right, so if we arrive just before train C, so we could board this train, but it doesn't go to Banbury, which means we'll have to wait for train D, which is the time after that. So difference between 11:15 to 12:47, that's how long we'll have to wait for the train, but we start at 11:12. So 11:12 we arrive, and the next train that goes to Banbury, just confirm it again, is the 12:47. So let's put that down. What's the time difference here? 11:12 to 12:12. 11:12 to 12:12 is 60 minutes. It's an hour. So we got to go 12:12 to 12:47. So 12:12 12:47. That gives us 12:12 to 12:42, which is an additional 30 minutes. Is 30 minutes, yeah, plus another 5 minutes, because that'll be 42 minutes to 47. So that gives 30 plus 5, 35 minutes. So therefore we have to wait 60 plus 35, which is 95 minutes. So here we have, is that right? 12:12 to 12:42 is 35 minutes. 60, 70, 80, 95 minutes. So the wait time is 95 minutes, which is the same as 1 hour 35 minutes. So 1 hour 35 minutes. Right, question 11. Charlotte has a map of a village. The scale on the map is such that 1 centimetre represents 25 metres. On a map, the church is 7 centimetres from the village store. What is the real distance from the church to the village store? So we know that 1 centimetre is equal to 25 metres. Therefore 7 centimetres is that multiplied, so 25 times 7. 5 times 7 is 35, in the 5 and carry the 3. 7 times 2 is 14, plus 3 is 17, so therefore 175 meters. Don't forget the units. Part B. Charlotte calculates her car is parked approximately half a kilometre from the church. On the map, how many centimetres would represent this distance? So half a kilometre is the same as 500 meters, because a kilometre is 1,000 meters. So divide. So to get to centimeters, 1 centimeter is equal to 25 meters. Therefore, to get the centimeters, we will need to do 500 divided by 25, which we can do here. So 25 into 500. 500 into 50 is 2, gives us 0, 0, and then we have the additional 0, so then the answer here is 20 centimeters. Right. Question 12. Write down the next 2 numbers in each of the following sequences: 0.4, 0.04, 0.1, 0.16. So here let's do 0.1 minus 0.04. What's the difference here? 10 minus 4 is 6. 0 minus 0 is 0. So there's a difference of 0.06. And what about 0.16 minus 0.10? So difference of 0.06. Let me write that correct, a bit more clearly. 0.06. So between them, and that's a 0.06. So the next 2 numbers will be 0.16 plus 0.06. 6 plus 6 is 12. Carry the 1. 1 plus 0 is 1 plus 2. And then we get that. So the next number will be 0.22 and then 0.22 plus 0.06. 2 plus 6 is 8. 2 plus 0 is 2, 0. So 0.28. The next question, B 3, 9, 27. So the difference, 3 times 3 is 9, 9 times 3 is 27, so it looks like it's a difference of 3 here. So the next one will be 27 times 3, 7 times 3 is 21, put the 1, carry the 2, 3 times 2 is 6, plus the 2 is 8. So the next one is 81. Then we need to do 81 times 3. 1 times 3 is 3. 8 times 3 is 24. So the difference here is 81 and then 243. Part C, 0.3, 1/3, 11 over 30. So we've got to see what the differences between these are. So 3 divided by 1. 3 into 1 we can't do, so we need to add a 0, but in order to do that we need to put a decimal place there. How many 3's in 10? That is 3, carrying 9, take the 1, 10 minus 9 is 1, bring the 0 down, 3 into 10, so it's a recurring number here, and it will always be a 3, because we're always coming back to 10. So we have an answer of, so let's just put 0.3, 0.333, and then 11 over 30. Let's put that into decimal places as well. So 30 into 11. How many 30s in 11? Yep, we can't do that, so we have 0, 0. How many 30s in 110? So 30 times 4 is 120, so therefore we have 3. And 30 times 3 is 90. Subtract them, so 0. We can't do 1 minus 9, so we need to steal a 1 here. 11 minus 9 is 2. So how many 30s in 20? We can't do, so we add another 0 there. So how many 30s in 200? That's 6. That gives us 180. 0, 0 minus 8 we can't do, so we need to steal a 1 from this side. So now we have 20, then we have 0 here. So again we've got back to the 200, so it's a recurring 6. So 3 numbers we have here are 3, 6, 6, 6 recurring. So for recurring we put a little dot on top of the last number. The difference between these two numbers is a 0.033 recurring, and you would see the same on this side, 0.0333 recurring. That gives us, so if I show you, so 0.333 recurring plus 0.033, that gives us 6630. So the difference is 0.033. So let's just add these numbers up. 0.366 recurring plus 0.3033. You've got to be careful here. I mean, make sure you got all your decimals correct. 6 plus 3 is 9. 6 plus 3 is 9. 3 plus 0 is 3. So the next number is 0.399. 9 recurring. And the one number after that, 0.399 plus 0.033. 9 plus 3 is 12. Carry the 1. 9 plus 3 is 12 plus another 1. So that's 3. Carry the 1. 3 plus 0 is 3 plus the 1, 4. So 0.432. 0.432. Question 13. Solve for x in the following equations. Part A, 6x plus 3 equals 21. Right, so we need to make x on one side and the integers on the other side. So if we do 6x, if we subtract both sides by 3, it will remove this 3. 21 minus 3. So 6x is equal to 21 minus 3 is 18. And then to remove the 6 from this side, we need to divide both sides by 6, because this is a multiplication of 6 times x. So x is equal to 18 over 6. 18 divided by 6 is equal to 3. So the answer here is 3. Part B, 15x minus 5 equals 75. First thing to do is expand this bracket out. So 15 times x is 15x. 15 times 5, there's a minus there. 15 times 5, we'll do it over here, but the answer is 75 there, but we'll do it. 5 times 5 is 25, carry the 2, 5 times 1 is 5, plus 2 is 7, minus 75 is equal to 75. So let's make 15x one side of the equation, so by adding 75 to both sides, 15x is equal to 75 plus 75, because we've move that over to this side, so we have to change that minus sign to a plus. So 15x is equal to 150. Divide both sides by 15, because this is multiplied on this left hand side, 15 times x. So by dividing by 15, we remove that 15 from this side, but we need to do the same to balance the equation on the other side. So x is equal to 150 divided by 15, and we know that 15 times 10 is 150, so x is equal to 10. So there we go, answer of 10. C, 3/4 of x plus 5 is equal to 26. So first thing we need to do, we need to move this 5 to the other side, so we only have an x value on this left hand side, and to remove it we need to subtract both sides by 5. So 3/4 of x is equal to 26 minus 5. So 3/4 of x is equal to 21. So 26 minus 5 is 21. Multiply both sides by 4, so we can remove this denominator. So 3x is equal to 21 times 4. 21 times 4. 4 times 1 is 4. 4 times 2 is 8. 84. So 3x is equal to 84. And now to get just the remaining x, we divide both sides by 3. So x is equal to 84 divided by 3. So let's just do that just over here. 84 into 3. How many 3's in 8? That's 2. 6. 8 minus 6 is 2. Bring the 4 down. How many 3's in 24? That's 8. And finish it off. 24 minus 24 is 0. So the answer here is 28. Question 14a. Let p be a prime number. Circle one expression below which could also be a prime number. So 2p, 7p, p minus 4, p squared. P being a prime number. So I think the first thing you need to know is that by multiplying a prime number you end up being a multiple of that prime number. So this will be a multiple, 2 times the prime, 7 times the prime will be a multiple. So p minus 4, come back to this one, p squared. So if you square two prime numbers they end up being multiples as well. So the expression must be this, p minus 4, but let's check this. So prime numbers 2, 5, 7, 11, 13. So let's check if this works. So 13 minus 4 gives us 9, so that's not a prime number. But 11 minus 4 gives us 7. So there's a prime number initially, which corresponds to this p, minus the 4 gives another prime number. So that's the correct answer. So by subtracting 11 minus 4 gives us 7. Other expressions become multiples of the prime number as we are multiplying. And 15. A farmer keeps chickens in an enclosure given below. If each chicken requires 3 meters squared, what is the maximum number of chickens that the farmer can keep? So what this will be is we would have to work out the area of this shape. That will give us an area in meters squared, and then we divide by 3, which will give us the number of chickens per meter squared. So that will give us the answer. So first thing we need to do is to work out the area of this shape. So we have a rectangle with a slight triangle on top. So why don't we split this along this line here? So we make shape A, make shape B. So we know that the entire length of this is 8 meters, but the entire length of this part is 10. So the difference between 10 and 8 is 2 meters. So therefore there needs to be 2 meters here. We know that this entire length is 14 meters, whereas this is 12. So 12 plus 2 gives us 14, so this is also 2 meters. So area of shape A is a rectangle, so that's length times width, 14 times 8. 8 times 4 is 32, carry the 3. 8 times 1 is 8, plus 13 is 11, plus 3 sorry is 11. That gives us 112 meters squared. So area of shape B so area of triangle is length times height divided by 2. Length is 2 times 2 over 2 equals 4 over 2 equal to 2 meters squared. So total area is equal to 112 plus 2 equals 114 meters squared. So we know that each chicken requires, one chicken needs 3 meters squared. So 114 meters squared would mean that we need to divide by the area that one chicken occupies, so that would be 114 divided by 3. How many 3's in 1? Can't do. And 11, that'll be 3, giving us 9 below here. 1 minus 9 you can't do, so still the 1. 11 minus 9 is 2. 3 into 2 you can't do, so bring the 4 down. 3 into 24 is 8. 24, 0. So answer is that we can keep 38 chickens. If you look at the marks, you're probably going to get a mark for working out the area of this and the area of that, and then the final mark is figuring out how many chickens you will need to be in that space. 16. Otto knows that his car requires 27.5 litres of fuel to drive 110 miles. He wants to drive from London to Edinburgh, a distance of 405 miles. How much fuel will he need? So this is a ratio question, so we know that 27.5 litres equals 110 miles. So how much fuel, no, how much distance for 1 litre of fuel? So we divide both sides by 27.5, so 27.5 divided by 27.5 is equal to 110 divided by 27.5. So 27.5 times 2, 5 times 2 is 10, carry the 1, 7 times 2 is 14, plus 1 is 15, carry the 1, 2 times 2 is 4, plus the 1 is 5, got 1 decimal place, 55. So, and 55 times 2 is 110, so what we know is that 1 litre is equal to 4 miles. So what we need to do now is work out how much fuel will you need for 405 miles, which is just a division of 4. So 405, 405 divided by 4. So let's have a go at that. 405 divided by 4. 4 into 4 is 1. 4 into 0 you can't do. Bring the 0 down. So we need to add a 0 here because you can't do this division. 0. Then we bring the 5 down. 4 into 5 is 1. Bring the 4 down. 5 minus 4 is 1. 4 into 1 we can't do, so we need to add a 0, but we need to put a decimal place there. So 4 into 10 is 2. That gives us 8. 10 minus 8 is 2. So bring a 0 down here. 4 into 20 is 5. And that should cancel out. Yeah. So the answer is 101.25 litres. Given the scales below, what is the weight of one circle? So we have two scales here, one with 3 squares and 2 circles, the other side being 39, and the other being a square and a circle and 17. So what we don't know is that how much does each square weigh in relation to each circle. So you would think that it's equal, but it's probably not. But the best way to do this is to come up with 2 equations. So let's call this 1 and call this 2. So what we have is let x equal a circle, y equal a square. So what we have here is that 2x plus 3y, because we have 2 lots of circles and 3 lots of squares, is equal to 39. That's equation 1. Equation 2 is x plus y is equal to 17. So we need to substitute in here. So if we go along like this, so it's quite clear. Y is equal to 17 minus x, because we're trying to solve for x, because we want to know what the circle is. So we remove the y from this equation, so we substitute y in equation 1 with 17 minus x, so we get 2x plus 3 bracket 17 minus x is equal to 39. So let's expand this bracket out first. 2x, so 17 times 3, let's do that over here. 7 times 3 is 21, carry the 2, 3, 4, 5, 51. So plus 51 minus 3x is equal to 39. So we've got to rearrange this, and I think we'll do a double rearrangement. We'll take this number to the left and we'll take all the x's to the right, so we can keep the big numbers together. So 51 minus 39 is equal to 3x minus 2x. So we need to do 51 minus 39. Can't do that because 1's small, so we steal a 1 here. 11 minus 9 is 2, 4 minus 3 is 1, is 12. So we have 12 is equal to 3x minus 2x is equal to x. Therefore, the weight of one circle is 12.
18. Harry is 5 years younger than Ron. In 4 years' time, Ron will be twice as old as Harry. Find Ron's present age. Make sure you show your working. Right, so there's quite a lot of information here. So let's start thinking about this. Let's put Harry's age equal to x. So we know that Harry's age is x. So Ron's present age is 5 years Harry is 5 years younger than Ron. Therefore, Ron, present age, x plus 5. So, in essence, Ron is 5 years older than Harry. Okay, so now we work out what the age of Harry is after 4 years. So, in 4 years' time, so age of Harry after 4 years, that'll be x plus 4. So he's x is the age now, and in 4 years' time you add another 4 to that. That'll be Harry's age after 4 years. So now we'll work out what the age of Ron is after 4 years. So using this same equation, age so age of Ron after 4 years is x plus 5, which is his present age, plus 4, which is 4 years' time. So he will be Ron in 4 years' time will be x plus 9. Right. So let's draw a line under this. So now we have the ages present and we have the ages in 4 years' time for both Harry and Ron. In 4 years' time, Ron will be twice as old as Harry. Okay, so that's another part of the question. So let's write that down. 4 years' time, Ron will be twice as old as Harry. Ron be twice as old as Harry. So after 4 years, we can write an equation for this. Ron will be x plus 9 in 4 years, which will be the same as twice Harry's age. So we double x plus 4. So in 4 years' time, Ron, which is x plus 9, will be twice as old as Harry. And this was present day, and then we doubled it. So if we expand this out a little bit, x plus 9 is equal to 2x plus 8. We open up this bracket. We can solve for x. That will give us Harry's age, and then we can work out how old Ron is. So here we go. X. Okay, let's just do this. So we're going to have to shift these around. So if we take the x to this side, subtract both sides by x, and then subtract both sides by 8. So let's write that out. 9 minus 8 is equal to 2x minus x. X. Okay. So 9 minus 8 is 1 is equal to 2x minus x is x. So now we know that Harry's age is x. But the question is, what's Ron's present age? And Ron's present age we worked out was x plus 5. So if we work that out, Ron present age is equal to x plus 5. And we know x is 1. 1 plus 5, 6. So therefore, Ron is 6 years old. Question 19. The two large right-angled triangles are identical. All internal triangles are similar in shape to the larger triangles. So in essence, these smaller triangles are similar in shape to these larger triangles. So I think we can actually say that the total area of both of these in terms of large triangle is the same. Which is larger, the shaded area in the triangle on the left or the shaded area in the triangle on the right? You must give a reason for your answer. Okay, so I think what's important here is that it said the right angled triangles are identical. So that means, as I said previously, the both areas seem the same. So what we can do is we can work out the area that is shaded in each of these triangles. Let's do that. So if I call this left triangle triangle 1, and this triangle triangle 2, so which is larger? So let's work out the shaded area of 1. So shaded area, so okay, hold on. So if we do shaded area, how many total triangles are in here? So we can count them up. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the total number of triangles, and how many of them are shaded? 1, 2, 3, 4, 5, 6. 6. So if we divide by 3, that's 2/3. So 2/3 of that triangle 1 is shaded. And 2. So I'll go back to this. Even though the triangles here look larger than on the left than on the right, because the true triangles are identical and all internal triangles are similar in shape to the larger triangles, the total area is actually the same. So in essence, we're just working out the fractions of each, and then we work out which one's got the biggest fraction. So shaded area of triangle 2, how many total triangles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And how many of those are shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So we can divide by 2 here, so that gives us 5/8. Now let's work out the difference between the two triangles. So that'll be 2/3 of triangle 1 shaded minus 5/8 of triangle 2. So we're subtracting fractions, so we need common multiple between these. Simplest way to do this is to multiply the both sides by one side by 3, do a cross multiple, and then the other side by 8. Or you can work out the multiple of both of this is 24. So what do we need to do to this side to get 24? We multiply by 8. This side to get 24, multiply by 3. So that gives us 8 times 2 is 16 over 24 minus 5 times 3 is 15 over 24. So scroll down a little bit. So that will be 16 minus 15 over 24, which is equal to 1 over 24. So we subtracted the left triangle from the right triangle, and because this didn't come out as a negative number, it means that the shaded area on the first triangle is larger than the second triangle. So the the shaded area of the left triangle larger than right based on total on fractions of shaded area. Right. 20. This looks like a tricky question. The board shown has 32 cells, one of which is labeled S. Okay, S is down here, and another F. F sitting in the top right. The shortest path starting at S and finishing at F involves exactly 9 other cells and 10 moves, where each move goes from cell to cell horizontally or vertically across an edge. So it's either going this way or that way. How many paths of this length are there from S to F? You must show you're working. Okay, so we have to get from S to F, and it's saying that the shortest path involves exactly 9 other cells and 10 moves. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That will get you to F. So we've got to figure out how many paths of this length are there from S to F. So if we start from this point here, from S, there are two starting points. Two starting points. Maybe if I draw this, this would be easier to explain. So square, square, square. So that's S. So you can start from here and move to the right, or you can move vertically up, right? So maybe we can represent this as, so we can, in terms of moves, this as, so if we, let me draw that again, only this time, I will say you can move one step up or one step to the right. Okay, so, but along the edges, okay, so along the edges, we only have one way to travel. Single way to travel. Which means that we can only go horizontally along the edge or vertically, depending on where we are. However, every square not on the edge, not on edge, can be reached from below or from the left. So if you think about it, let's try and draw it again so it's a bit simpler. So if that's A and that's B, this is an edge. To get there, you can get a sum of these two, A plus B. Okay, all right. So let's fill the square. Um, let's see, hold on, how many? 1, 2, 3, 4, 5, 6. Okay, so we need to go 6. So what I suggest is let's just draw it out so we fully understand what's happening here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So that's S, and then we have to go 6 along here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. Okay, so, and then we have another square here. So this, essentially, I've drawn this shape here, and I've added this box. So we know that each move to move up and down is a single move, 1, 1, 1, 1, 1, based on this, A, B. But a corner point will be A plus B. So let's just do this, 1, 1, 1, 1. So to move to the right, you'd have to move one move, and again, 1, 1, 1. But to get to this square, you can either go to the right and then up, or we can go vertically and then to the right. So there's two ways you can get here. So that's 2. Okay, so then maybe we can just fill out the square using this method and adding up the numbers until we get to until we get to F. So let's do that here. So each of the edges is 1. So to get to this point is 2. 2 moves from S. To get to this point is 2 plus 1 is 3. 3 plus 1, 4. 4 plus 1, 5. 5 plus 1, 6. Let's do the same here. 2 plus 1 is 3. 3 plus 1 is 4. And then 5. 5 plus 1 is 6. Okay, so now to get to this point here is there's only one move because we don't have a number here. So there's only so you need to so it's still five steps. So 5, and this one here would still be 5. And again here, 5 plus 0 is 5. 5 plus 0 is 5. 5 plus 5, because we've already made 2 moves up here. So that's 10. 5 plus 5 is 10. We can do the sums here. 6 plus 5 is 11. 11 plus 5 is 16. 16 plus 10 is 26. Same here. 11, 16, 26. So therefore, to get to f is 26 plus 26. Let's do that over here. 26 plus 26. 6 plus 6 is 2. Carry the 1. 2 plus 2 is 4. 5. So therefore, there are 52 paths, right? So let's just summarize this. So f is 5 steps above, let me write that quick cleanly, above and 5 steps to the right. 5 steps to the right of S. Okay, so you know that f is 5 steps above and 5 steps to the right of S. Each of the 10 moves, can only be upwards or to the right. Upwards and to the right. So based on what we've just done, so we have actually done that. It's only upwards or to the right. So there are 52 steps from S, or paths from S to F. So that's a very tricky question. I think getting to this point in this paper is quite difficult. These are quite detailed questions and you have to work diligently, cleanly. But if you notice, this last mark is only worth 2. So let's write the answer down. Actually, I forgot to do that. So it's not that it's a large mark question, but so it's essential to get all the other questions right, the ones that are a little bit easier to complete, and then work our way through to this point. So that concludes the end of this paper. It was a pretty difficult paper, and I hope you guys have followed it through. And if there are any questions, please leave them in the comments below. But hopefully I'll see you next time when I run through another 11 plus paper. Thank you very much for spending the time with me to run through this paper. Have a great day. Thanks. Bye.